Welcome to Desk Ladyada.
Hey everybody, and welcome to Desk Ladyada. It's me, Ladyada. You can tell I got my hair repinkified, which is good. It means nature's healing.
Yep.
With me, Mr. Ladyada on camera control.
That's right.
Go
ahead.
No.
Now I was going to say, we're going to do this show. We have a thing we're doing. Let me just tell everyone, because you might get your news from all sorts of different sources. New York is amazing right now. There's theater, there's art, there's events everywhere.
We bumped into a bunch of people.
We were walking around New York City, and we saw people who spanned all across the U.S., and Lamore ran into some MIT folks. So, it's happening. It's happening. Come visit New York over the winter. Go to all these things.
Fall is like the best. Spring's good,
amazing.
But fall is like prime. Good shopping.
It's amazing. The restaurants
events,
are open.
Pop-ups.
It's no big deal. No one cares about the vaccine thing. You show your thing and go in and you have a great time.
Yeah.
It's awesome. Okay, so let's do some electronics.
Okay, cool. So we got a 20-minute show tonight because I'm going to get some dinner. We got a reservation, which is cool. Restaurants are back too. And, okay, so we got a couple things. First up, getting back to the old designs. I've been trying to kind of catch up with designs, like one or two a week, because I took a little bit of a break. So the KB2040 is the board that I worked on this week, which is a keyboard controller. Because remember, I did all that keyboard stuff kind of in prep for the macro pad and the AdaBox. And I was like, a lot of these kits... they use a Pro Micro. So let's go to the overhead real fast and I'll show off what I'm talking about.
Yeah, I work with the folks over who do a keyboard newsletter. It's on our site and everything. And I was like, hey, what would be the best thing possible with all this? And so we're going to do some giveaways with them. Right now, we're a sponsor of one of their contests. But you'll see this in all the keyboard sites soon because we wanted to do state-of-the-art, best thing possible. Python's on it. So, Ladyada, what did you do?
So this is the Pro Micro. So this is a clone of, a DIY build of the SparkFun Pro Micro, which has a certain pinout to it, and it has a 32U4 Arduino compatible chip, and it's got an Arduino compatible bootloader on it, and it's got a certain row size and row of pins, and the capabilities, the way the power pins are hooked up and what the chips can do, is very specific. This one has an SMT, which I really don't like. This is an SMT micro USB connector, which is not so great. And so we're like, well, we stock the Pro Mini, and we'll probably stock the Pro Micro as well. But we wanted to do something that was, because we added HID support in CircuitPython for the RP2040, and people are really liking it. If you're using CircuitPython on the RP2040, chances are 50% of the people are doing it because they want that native HID support for keyboards. And we did key matrix scanning, and we're adding right now we're working on asynchronous concurrency work in CircuitPython, so people can do more of that, and that's kind of coming along. So we wanted to make a board that you could be kind of drop-in compatible as much as possible. Now, I will say a lot of people who use keyboards are using something like QMK, which is this very interestingly designed and developed software. It's definitely got a little bit of the, one person developed it, and it's very specific about how it works, and it requires an RTOS, although I don't remember exactly which one. And so not all chips are supported. But, for people who just want to do plain Arduino or they want to do CircuitPython, the RP2040 is supported there, even though it's supported in QMK. Although I think eventually someone's going to add QMK support, but I looked at it and I'm not doing it because I got a lot of shit on my plate. So this RP2040 board, I was actually inspired a little bit by the Elite C, which is a derivative of the 32U4 board, but with USB Type-C and a couple other benefits. So let's look quickly at the computer.
That's why open source is great, because we're all building on top of multiple things.
And this is
people build off our thing.
This is a really good looking board. I gotta say, this is a board is really nice. So one thing I thought was kind of nice is that they broke out the D plus and D minus pins up here, and I actually thought that would be really useful because a lot of times if you're if you're doing USB stuff, and especially with keyboards where it's mounted on a board, but then maybe you want to have a different kind of connector, or you want to have the cable go elsewhere, getting to the power ground pins is really easy. Those are exposed through the raw pin or the V-bus pin. But what you don't have access to is the data plus, data minus. And those are, sometimes they're brought out in some way. So one of the things I did in my design is that there's this kind of like 2 pins at the top. This is castellated, which is why it's got that weird, you're like, why do you have this really long pads? This is how you make castellated pads, by the way, in Eagle. Is it the official way? I don't know. But this is the way that works. You basically have 2 sets of holes. You have 1 set of holes here, which you actually can't quite see because this is overlapping. Maybe if I press the... No, I will show you. But basically, there's a hole here, and then you have an oval pad that overlaps with it. And I'll show you on the overhead what it looks like at the end. It comes out quite nice as a castellated pad, and the board houses know what you're talking about. So this pin here is D minus, and down here is D plus, and then there's this jumper to let you get access to like the raw USB power. And let's go back to the Elite C. Other than that, it's got USB-C, which I like. This has a sunken USB-C, which I'm kind of into, but it's also would take up a lot of space. So I decided to go with like a plain mounted one. And this board also has edge connectors here, which I decided I wanted to STEMMA QT port and 2 buttons, which is actually very similar to SparkFun. They made a RP2040 Pro Micro, and I was like, that's a really good idea. So I kind of combined kind of a little bit of both.
Fun trivia, the SparkFun Pro Micro Arduino is the only open hardware certified Arduino.
Oh, that's so?
Yep.
The Pro Micro or the Pro Mini, really? I don't know that.
Yeah, whatever the ones the SparkFun did. Yep.
Yeah, okay, cool.
That's a trivia thing.
That is cool.
That's a new segment.
check out Desk Authority, because they do have a whole bunch of these boards. And then this is example, because I was like, what are they used for? So there's often these little kits. So this is like a 16 key kit, and this is what it looks like in the end. It's like it's a 4x4 key kit, and you DIY it. And basically what's nice about when people use Pro Micros is they're it's a very standard small pinout that people use, and then all you need is some through-hole diodes along with it, and these through-hole buttons. So it basically takes a project that would be... it's interesting. It's people like, how are people going to prototype with SMT microcontrollers? Because like back in the day, you could get DIP microcontrollers. Like, that Mega series came in DIP. But none of the USB chips come in DIP. What are you going to do? Well, you end up just using kind of like a module-y type thing. And the RP2040 Pico is much, much cheaper. Of course, it's sold kind of like at cost from Raspberry Pi Foundation, but it's much, much bigger. And I wanted to have something that's pin compatible. So one of the things I did while debugging it is, you want to make sure that all the pins are aligned right. And we have the pretty pin script that we worked on a couple months ago that allowed us to auto-generate these very beautiful pinout diagrams. And the way that works is it's basically just a total like disgusting mess of Python code I wrote. And it actually parses out... you give it this CSV file, which tells you each GPIO what it is, and then it parses the pins.c file in CircuitPython, and it parses the Arduino pin definition file as well. If you look at the code, it really does some really horrible, wonderful things where it includes the Arduino core and then compiles it with a main C that printfs the pin definitions out instead of trying to actually parse it, because it's easier to just have it print out all the pins for you. And then it kind of mushes it all together and gives you this combination which displays the CircuitPython name, the Arduino pin name, and then all the peripherals that are available on those pins in color-coded order. And it's a total pain to add new boards, but once I've added a board, we can kind of rip through and do them. One of the reasons I did this is, one, I want to document boards because people are like, I want these pin diagrams, and folks from the community were like, hey, I'll generate a pin diagram for you. And they were very, very kind and were very, very grateful for the people who've done that. However, there was always one typo. And it's not their fault. It's really, really, really hard to make a pin diagram from scratch without making a human error. It's like everything's like PB0100, but that's not necessarily D0. It's very easy to get things mixed up quite easily. And so having this automatic generation, first off, we get beautiful diagrams, but also when I'm checking that I muxed all the pins right, I get a big picture of all the pin muxing, which really helps make sure that, like, okay, do I really have a UART on D0 and D1, and I can read over here and be like, okay, yeah, I have, a UART, TX is in the right place, RX. They test them in software, but it's always good to just have another thing. The analog pins are in the right place and they're all labeled right. It's just another check. So this is probably going to come out soon. I'm going to try ordering from PCBWay. If you click on the advanced PCB search, it takes longer, but they do have pink available. They have some cool colors, orange and transparent and gray.
We're going to have all of the
pink.
colors eventually for all of our boards in a variety of ways, so stay tuned to that.
Yeah, just remember you have to click on advanced. It's not the standard or proto. It's
Yeah.
just, you're going to pay a little bit more and it's going to take 2 weeks. Okay,
Right.
So that's that and that and that. And so the next thing as we lead in, so it's like, what's the next board I'm trying to finish, is, so I'm setting up the keyboard 2040 that PCB was sent down. I'm going to get the tester, and so we'll fab that soon. Thank you very much. And then next step, I wanted to make a little stepper motor driver. Also, these are kind of a standard pinout, and I wanted to. People tend to use like the Allegro, like I think it's the A9488 or 9844 or something. It's a very standard stepper controller that's used in 3D printers. Obviously, I don't want to manufacture 3D printers, but these stepper motor controllers are kind of in a very standard pinout, and I thought it would be cool to make a feather wing, maybe that takes them, or like a motor hat. And so I was like, I want to make one as well. And we saw that ST has a nice motor driver. They're starting to compete with very high step resolution. I think it's like 1/32 of a step, which is really great. And ST makes really good motor drivers. And so I thought I started sketching out the design of one of these controller boards using the STSPIN low voltage stepper motor drivers, low voltage 10 volts, which is still well within a lot of people's voltage driving range. They want to drive 8-9 volts, maybe 5 volt stepper motors, and up to 1.3 amps. One thing that was interesting is as I was doing the design for this is that to do, there's stepper motor controlling, but there's also current limiting, and that's important because with stepper motors, you're often, as they heat up, the resistance changes a little bit. You want to drive them at a constant current, and so there's this sense resistor. And the sense resistor is a current sense resistor. It's not a current mirrored sense resistor. So this resistor actually has to be quite high wattage in order to handle the 1.3 amps times 1.3 amps times whatever the resistance is that sets that current. So it takes a little bit different. I think we covered surface mount resistors, but I wanted to do a great search where we talk about not just resistors, but current sense resistors. So if we have a last question before we go to the great search, that'll be the great search.
We're going to do a great search right now.
Okay.
Where in the world is that part I need? The great search with DigiKey.
The Great Search brought to you by DigiKey and Adafruit. Thank you, DigiKey, for supporting The Great Search every single week. Ladyada uses the power of engineering to find you all the things on digikey.com. Ladyada, what is The Great Search this week?
Okay, so this week I am working on the STSPIN breakout board. It's an ST stepper motor driver with current limiting, and it uses resistors to make sure that the current limiting stays within the desired limit. To do that, we need to have this breakout board that we're designing, and it's a fixed size. We need to have these kind of large current sense resistors. So I want to show how I found the current sense resistors of my dreams. Let's go to the computer. I'll show you the design. So this is the data sheet for the STSPIN 220. To see the stepper motor, and then there is 2 resistors, one for each coil. And this resistor actually has the current pass through it, and so it's quite a high power resistor. And if we search for, you can determine what sense resistor you want. The sense resistor sets the current limit. So I'm going to follow the data sheet recommendation values, but of course, depending on the stepper motor you want to drive, whether you want to drive it at a full 1.3 amps, or a little bit higher, maybe 1.5 or 1, whatever, do the math. But in this case, it's 0.3 0.33 ohms. So it's 330 milliohms, right? Because it's current sensing. You want to measure the voltage going over it, and the current is quite high. So in this case, we're dealing with a 0.33 ohm resistor times, maybe 1.25 amps times 1.25 amps. So it's over half a watt, right? Because it's voltage times current is power, but we don't know the voltage necessarily in this case, so it's just current times resistance, which is like the same thing. And it's over half a watt. And that's not, usually when people are just buying resistors, you're buying 0402s or 0603s, you don't care about the wattage because it's a pull-up resistor or a signal resistor or a voltage divider. The amount of current going through is like under a milliamp, and so that you're never going to get over a quarter watt or a tenth of a watt or a 16th of a watt. And so you can use these little itsy bitsy resistors. But in this case, these current sense resistors, because there is a full amp plus going through them, the wattage is quite high, which means physically the package has to be larger in order to dissipate that much current, which is why you see on like our INA 219 or other current sensing or power sensing breakout boards, there's this big ass 0.1 ohm resistor. That's what the current is passing through, and it has to be really large in order to dissipate that heat. One thing, early in your engineering design, you'll probably spec the wrong size resistor for a current sense resistor, because it's easy to be like, oh, I'll just put an 0805 with 603, and then it'll immediately overheat and melt off, and it'll be super cool because this resistor will just go right off your board, pop. So let's go to DigiKey to find a current sense resistor. So again, I'm going to follow that datasheet recommendation. They say 330 milliohms, 1 watt. Why 1 watt? Because you don't want to have a half a watt if it's, you give yourself some headroom, right? You never know. There could be ambient temperature rises. It could be plus or minus 10%. So they recommend 1 watt, and we'll go with that. So in this case, we can look for this resistor. I know it's like, you think you search for current sense, but even though current sense resistor is what I would consider a subclass of resistor, it's not sold separately than plain resistors. There are chassis mount resistors and such, but in this and adjustable power resistors, which are kind of specialized. But in this case, it really is it's just a resistor with a very high wattage. So first off, we're only going to look at stuff that's in stock and active, because I want to purchase them and I also want to spec them.
You might want to purchase them.
I want to purchase them.
Make sure you can purchase the things that you want.
Well, there's always like thousands of, the resistors, there's literally a million different resistors. And so I'm like, look, I just want to get the ones that I can buy. For resistance, you can put in, I'll actually use these limit boxes. So let's go from, 250 to 350 milliohms. So that's kind of nice. It will select for me
That's nice.
the area. Like I said, you can't select both. And then, of course, the most important thing is that wattage. So under power watts, go down here and select 1 watt. Now, there is 0.75 watts, and I don't know, you can also select that. But I'm going to stick to 1. And then, I think as I really, because I'm just laying out the design to test it, as I do more testing, I can actually verify how much wattage am I burning off of this resistor, and then if I can get away with 0.75, because it's still more headroom than necessary, but I have to want to verify that. Tolerance 1%, 5%, it doesn't matter. I mean, current sense resistors are not going to get high precision because they're just differently made. They're meant to dissipate a lot of heat, and in fact, if you look, there's some cool weird resistors out here. First off, they can come in, diode MELF, because physically they're just larger. They can dissipate more current. See, there was a really cool one. I don't know if it's... There's one where you could actually see there was 3 elements in it. Let me go with stock. Is it this one? No, there was just, oh yeah, here it is. So this is kind of cool. I saw this and I was like, oh, that's kind of interesting. So you can literally see there are 3 resistors in parallel, so that each one can dissipate, and it has a little bit of this space in between them. So it's the old hack of you need a half watt resistor, you only have a quarter watt, you pick twice the resistance and double them up, and you get twice the wattage and half the resistance. Okay, same thing, but done for you in SMT format. So one thing I do want to note is, which I've never seen before, and you do have to watch out for, is it's like, it's an 0805, but it's wide style, right? It's the wrong way. It's like couch style or whatever. It's you don't connect across the pads, and that's important because usually for this resistance you get 2512, right? Which is kind of massive for a resistor. I mean, we can. I think this is the resistor, right? Yeah, so this is 1206. Here's a 1206 on my board. And if you change this package to 2512, it's like half the board is this resistor. I couldn't fit two of these. And so in this design, normally I go with price and I don't care about size because who cares? But like I am fixed, I have to have it in this package so that this breakout board can fit into like the standard 3D printing stepper motor controller. So the size of it is important. In which case I'm going to do what I normally don't do, which is make sure that I don't have these massive packages. So I'm going to say, 1210, 2010. I don't even want 2010, to be honest. I kind of want the smallest possible. I think kind of 1218 or 1206 is the largest. And that'll really reduce the number down. And let me see if I can see what... This was the 0805 wide, but this is a weird package. Oh, okay. So what happened is because it's a weird package, it actually doesn't appear here anymore. Aha. So let me go back. So under supplier device, I think I need to click this little tick. Yeah. So what I ended up doing is that the one I found is... Oh, interesting. It did not... It didn't... One moment. It was, let me get rid of this. Package case. Oh, okay. So yeah, it's sometimes called 0805 or 0508. So I did find this one, which I really liked because it has 48,000 stock, which I really like. However, like I said, it's weird. It's like sideways style. So I actually have to, in EagleCAD, make a new package because there actually is no default resistor package that I've already used that is this like wide style. But what's nice is that it's a really good price. It's like, under 20 cents per resistor, and it's 0805, which will like fit quite nicely. It's just backwards. So, one thing I learned is that, as you saw, when you're searching for the packages, just be careful because it's like, you call this 0805, but it's actually not. It's 0508. And I see this whenever you're dealing with stuff like resistor networks and other like kind of non-standard, like not jelly bean resistors and capacitors. If they come in a slightly unusual package, sometimes you have to be a little bit flexible on how you use the search terms to determine it, because this would be categorized under 0805, even though like technically it's not. And then of course, don't forget you have to create a new package layout in KiCad or Eagle if it doesn't exist yet, because this is an unusual package. But that said, this is a very small resistor for this size, and it'll fit very nicely in my design. So I haven't done the layout for that 0508, but it'll be about this size, just a slightly different layout. And this will give me plenty of space. I can have two of these and not worry about taking up too much space on my tiny little board. So current sense resistor is very interesting. I've never had to pick one based on size, but as long as you're kind of flexible with your package options, you can get something quite small, and there's a lot of it in stock.
And that's a great search.
Where in the world is that part I need? The great search with DigiKey.
Okay, cool.
Okay, one quick question.
Yeah.
Then one is for you to answer, then one I'll answer. So since all this part shortage stuff, how many new Eagle footprints have you had to make because you're, using different parts than you usually do?
Well, I'm actually not using different parts. I'm trying to use the same parts that I can get. So I'm actually being a little less
You're not redesigning. You're just like.
I'm not redesigning for new different things. I'm trying to design using existing things, if that makes sense.
And then someone was asking, "Am I doing this remote?"
No,
I'm
you're
actually.
physically.
I'm like 4 feet away.
He's just closer. Closer. Hi. He's right there. Although it'd be cool if that was green screened. Bonk.
Am I the puppet? Or are you the puppet?
Yeah.
Okay.
Okay, that's the show. Thanks, everybody.
Thanks, everybody. Thanks for
more
coming
live
by.
shows
Lots
this
of
week.
good conversations, the chat, and more. Thank you so much. We'll do our weekly shows all week, and we'll see you next week. That is your Desk of Ladyada for
Bye.
this week.